All right, guys, today's learning plan is all about data, what it is, how it can be classified, and then how it can be expressed visually, and then how to read it. So, we're going to talk about 5 or 6 types of graphs or charts today, and then we're going to do some sample problems, just kind of what you can expect to see in IXL. So basically, when you hear the term data, I mean, really, none of us have probably been in a time where data has been more broadcasted than the past couple year and a half, right? With COVID, I mean, data is every day, all day. Um, if you want to seek that information, it's very data driven, and really all that is a collection of facts, right? We're collecting facts that we can learn from something, and hopefully we can represent that data visually. It's really helpful when it's represented visually, so we don't have to look at a ton of numbers and not really know how to make sense of them. We can be presented with a graph or a chart and just kind of organize it better, right? So data is really useful when it's organized or presented versus just giving us all that information. So data is really used a lot in the real world. Just the thing that comes to mind most, I already mentioned COVID, but just the media, right? We want to know, like, these charts that we're seeing, are they accurate? And are they really showcasing what it is they want to show or what they want us to think about the data we see? Data can be either qualitative or quantitative. So when you think qualitative, I want you to think of the word quality. Okay, so for example, like our GED HSCD programming, in my opinion, is a great program, but our numbers aren't high. We don't have as many students in our classes as you would see in a college math class, for example. But we can share a lot of data that's of quality. And really, when you think of qualitative data, you want to think of data that can be described. So I would, like I said, I would like to think our program is good, and it would be described as being really helpful, right? Or the instructors are caring, or whatever it is you want to say about the program, but it can't necessarily be measured. Qualitative data can't really be measured. It's more opinion or feedback based on a set of data. Quantitative, I want you to think quantity, the prefix of the word, the quantity, and quantity is number driven. So quantitative data can be number driven or counted. It has a quantity assigned to it. So for example, I had 11 students in class this morning. That would be considered a quantitative data because I can count how many students attended. Okay. So data really falls in these two buckets, qualitative data and quantitative data. I would say that quantitative data has more like value to it or more weight to it because it can be almost proven, right, with a number being attached to it, but doesn't discredit qualitative data. So qualitative data, an example of that would be students in the HSCD program enjoy their instructors, something like that. I realize this is all on one screen for you guys, or one big line, but that would be considered qualitative data. If I ever sent you a feedback form, which I know I have, I gather that feedback, and that's more qualitative data for me. Or even just the fact, like, Amy is wearing a black sweater. Qualitative data. It can't be counted per se, but it could be seen, right? Or an opinion, like the black sweater, right? Quantitative data can fall into two buckets. So remember, quantitative data being number based, or it can be counted. So down here it says discrete data can be counted. So for example, like I shared an example, 11 students were in class today. That's an example of discrete quantitative data. Okay. Where continuous data can be measured. So if we think of our full development, growing up into an adult now, we obviously got taller as we grew, right? So our height is continuous. Sure, eventually we kind of plateau, right? We kind of have a height as an adult, but height can be considered a continuous quantitative type of data, or weight, right? Or your TABE score. Your TABE score can fluctuate, right? Whatever it was today, it will change the next time you take it. It can go up or down, really, right? A TABE score or your GED test score would be another example. These are just examples of continuous scores. They can kind of ebb and flow. So this is just like a big overview of what data is, and now we're going to get into specific types of graphs and charts. So ways that data can be shown are many ways, but sometimes it's best to use a specific type. So for example, a bar graph is a geographical display of data using bars of different heights, So for example, here this reads, in a recent test, this many students got these grades. So 4 students got A's, 12 students got a B, 10 C, and 2 D, right? And this is this data represented in a bar chart. So we really have these two axes. This bottom axis is our x-axis. Don't really need to know that today. This is our x-axis. This is our y-axis. So bar graphs are really good to use when you have categories. Okay. So for example, here we have a category of our grades, A, B, C, and D. And then we can just showcase, okay, 4 people got A's, 12 people got B's, and so on. So you're just representing this data that's in a table form more into a bar graph. A histogram is very similar to a bar graph. It's just the big difference is the data is continuous. Okay, so for example, if you look here, a bar graph has these separate categories, right? I don't know the context of this graph, but we have countries on the bottom, it looks like, right? And specific dollar amounts attached to each country. And there's gaps between each bar graph, right? Versus a histogram has a range. So all scores here between 100 and 150 live in this bucket. And it looks like there's 20 scores between 100 and 150. The next bucket, and see how it's continuous, they're touching, is 150 to 200 and 200 to 250 and so on. So that's the biggest difference between a bar graph and a histogram. Bar graphs are separated by specific categories, and a histogram shows a range, right? That doesn't really, we don't stop. We don't have specific categories. It's just this range on the bottom for our scale down here. So for example, tree height. So it looks like here, I don't know, maybe 4 trees have a height between 100 and 150, right? Or 30 trees have a height between 150 and 200. So again, we see this range down here, not necessarily categories. So that's the big difference between bar graphs and histograms. When you guys are on IXL doing your homework, you'll have questions pertaining to how to read these charts, but then you'll also be creating them too. So for example, this last one, they may give you this information. 4 students got an A, 12 got a B, and so on. And then you just have to click here, and you would like click and drag your mouse up to 4. And the B's, whoops, that's not a very straight line. You would just click and kind of hold down your click to make that bar graph, which you'll see when you get to your homework. Another type of graph, which uses in the media a lot, is called a pictograph. And it's a way of showing data using images. So it's just kind of fancier looking if you think of it that way. So here it says 4 friends play a lot of tennis. Here's how many games they played this year. So we can see 1 tennis ball represents 20 games. So John played 40 games, right? Sam played 20, 40, and then a piece of a tennis ball. And if we look right here, we see that code is 5 games. So 20, 40, 45 games Sam played, right? So if a quarter of a tennis ball is 5, that's like dividing this into 4 pieces, right? Mary here played 20, 40, 60, 80, and then half of 20 would be 90. All right, so it's very similar to a bar graph, really, especially if you think of it like this, in here, like this, right? He's a little bit larger. Sam, Mary's did a lot, and Alex is somewhere in between. So it really is a bar graph. They just show it with these these little pictures within the graph, just called a pictograph. Next, we have a line graph. So this is very common, especially in the media, and you'll on your homework today too. And a line graph shows information that is connected in some way. Typically, it shows a change over time. Not always, but often that bottom axis, so right here, is the passing of time. And for example, here it says on day 1, I got 3 facts right on the test or whatever it is. Day 2, I got 4 facts right, and so on. So you can see here, day 1, they just put a dot here on the 3, basically. Day 2, we got 4 right. Day 3, we got 12 right. Day 2, we got 4. Yeah. Day 4, we got 15 right. And then you're just connecting these lines, right? And then that makes it into a line graph. But it shows a change over time. So it's showing, hey, my score is increasing, likely, the more I study, right? I get more facts right, the more I know, sort of thing. You could think of line graphs multiple ways. They don't all increase like this, for sure. Some line graphs decrease. So, for example, how much, maybe not yet, but soon, how much time we're spending outside, right? Maybe this is a specific month. October, we spend a lot. November, we lessen. December, less. January, less, because it's cold outside, right? So line graphs don't have to always go up. They can also go down. Kind of linked to a line graph is a scatter plot. And a scatter plot has points that show the relationship between 2 sets of data. So if we look at this data here, we have the x-axis here, the weight on the bottom, and the height up here. So this person weighs very little and is pretty short, right? So they're small. Versus if we go up here, we have someone who weighs a lot and is pretty tall, right? So you can see there's a correlation where this does kind of increase, but every dot represents a person in this case, right? So this person is of average weight, of average height, kind of the same as these ones. Whereas this person is just super tall, kind of mid weight. So it's really important to realize with a scatter plot, every dot represents a person in this case. This next one here, it has temperature on the bottom and then sales with a dollar amount on the y-axis. So it looks like sales increase as the temperature gets warmer, right? Sales are going up as the temperature increases. So you could think of like, there's no title to this graph, so I'm just brainstorming here, but you could think of like selling swimsuits. Chances are as the temperature increases, there's more sales in that, right? Or ice cream stores. Temperature increases, the sales go up. Air conditioner units, right? And so on. So just, again, this is just an example. I'm making those up, but we can see a trend here. Right? And that trend that I'm talking about is called a correlation. So if we see here, we see a bunch of different charts going on here. And you won't be tested on this on IXL, but it's still good to know. But the word correlation, I want you to think of like a trend, like I said. So if there's no correlation, that just means like there's random dots all over. There's no trend at all. Versus both of these charts up here, they kind of trend upward, right? So that's called a positive correlation. It's going up in somewhat of a line, right? And then that's just represented as 1, and you could think of that as like 100%. Like, hey, this graph looks legit. It's all kind of straight. This is like 100% correlated. Whereas this one, we can still see the trend. This kind of looks like this one maybe, right? If we put a line here, right, we have some outliers, but we can kind of see it has that correlation. Think of that like a 90% correlation, right? Or think of this one or this weight and height one as a 50% correlation. And this is a 0%. There's no correlation at all, no rhyme or reason of what's going on there. And as far as the negative side, it's the same exact thing. It's just represented with a negative number. It's like this is a negative 100% just because it's going down now, right? Negative 90%, negative 50%. So correlation is just the trend of the line and how it's kind of moving in a specific direction. The next type of way data can be represented is a frequency chart. And it's a special graph that uses vertical or horizontal columns to show frequencies. All frequency means is how many times something occurs. So another word for a frequency chart could be a dot plot. And we can see why down here we have all these dots going on. So just linking this table with this chart, here it's saying 6 people took 0 minutes to eat breakfast, meaning they didn't eat breakfast, right? They took 0 minutes to do it, so they didn't eat. So you can see here we have 1, 2, 3, 4, 5, 6 dots on this 0, right? We have 2 people that took 1 minute. So here's the 2 on the 1 minute. 3 people that took 2 minutes, right? 1 person took 12 minutes, and so on. So this is just called a frequency chart or a dot plot. And those, all the graphs we talked about so far, I believe, are all within the first 2 IXL lessons. So they might bounce around a little bit between a line graph and a bar chart and whatnot. But we just have like a big overall idea of what these are. And you get really good at it when you start practicing it in IXL. So I believe the first 2 lessons, I think, are what we covered so far.